Okay, well, people, let's have a look at this. What are we going to do here if you think about it carefully? Well, let's look at this little triangle here. Now, what I've got, I'm just going to redraw triangle OBE. Have a look at this. There we've got a right angle triangle there. Okay, this is B, E, and O. Okay, and it's clear because what they're also saying is if you take that, if you construct BE straight down there, you're getting it being perpendicular to that. They've actually given them in the exam, they would have given you that as a 90-degree angle. Goes straight down there, so those are perpendicular. I think it would have been important that they actually indicated that. But anyway, these two are equal to each other and they're equal to 1. Okay, so both of those are equal to 1. Now it's easy therefore to get, so if you've got that as 1 and this thing is equal to 1 here, it's easy to work out the length of OB using Pythagoras. So let's do that. We can say OB squared is 1 squared plus the 1 squared there. So OB squared is going to give you 2 there, and OB is, of course, the square root of 2. So now that's no problem there, because if the length of OB is root 2 units, then what would be the length of OD? So in other words, OB is the root of 2, BC is the root of 2, and so is CD. So the radius of the large circle would logically be 3 of those roots there. Okay, remember they would have had to give you that as 90 degrees as well, so you can work with Pythagoras. Okay, let's see if we've got all the information. An archer's target is made of 3 concentric circles, and we've got everything, yes. And I think it would be important to also have stated, I think, that BE is perpendicular to OE. That could have created a bit of a problem in the exam, but we'll just add it in. I think they forgot to do that. It might have been on the errata sheet. But anyway, let's have a look at this. So OB is the square root of 2. So what is the radius of the big circle? Is 3 root 2. And what is the center of that circle? Is 0, 0. Okay, so now it's easy to work out the equation of that very large circle. We remember we're going to write down the formula for the equation of the circle. The center is at the origin, which is 0, 0. Lovely question in the real world. And the radius is 3 of those root 2's there. So let's plug in what we have. So we've got x minus 0 squared plus the y minus the 0 squared is the radius squared. Okay, there we go. So this gives you x squared plus the y squared is, now careful, this is going to be 3 root 2 squared is 3 root 2 multiplied by 3 root 2. Let's do it slowly. X squared plus y squared. 3 times 3 is 9, multiplied by root 2 times root 2 is 2. So it would come to x squared plus y squared is 18. And that gives you the equation of this very large circle here. X squared plus y squared is 18, okay, of the very big circle. Remember the radius. What would be the radius, by the way, of the little circle? That would be root 2, so the equation would be x squared plus y squared is 2. If you square that, that would be for this circle there. What about for this guy? Well, that would be x squared plus y squared is 2 root 2 squared, which would give you the middle circle here, which is x squared plus y squared is 2 squared is 4 times 2 is 8. And there we've got it. So guys, realize that you need to know these in the real world, and it's actually not too difficult. It seems difficult, but it's not really that difficult at all. Okay, so guys, I hope you enjoyed that. In the next lesson, we're going to continue with some more exam questions on analytical, linking everything you did in grade 10, 11, and 12. We're going to look at specific exam questions. So stay with us, and let's have a look at those things that follow.